The purpose of this video is to share information about a free online coding program called Code.org. The founders of Code.org believe every student in every school should have the opportunity to learn computer science. The Code.org curriculum is actually created for students as young as the age of 5. And just very recently, they have extended their curriculum to middle school and high school. In this video, I will focus on elementary because that is what I teach. If we scroll down, we see some of our different options, and I'm going to go into the student. Okay, so when you get in here, you see that you can have your students sign up for an account. This way, all of their progress is saved as they move through the different courses and the different levels. There's a Course 1, which is ages 4 to 6. Course 2, ages 6 to 18. That's a huge range. The idea here is that you start your students out wherever they would be most comfortable. And if you start them out on something that's a little bit too easy, you can just quickly move them through to like the next course. Course 3 is ages 8 to 18 and 4 is ages 10 to 18. If you scroll down a bit more, you see there is an accelerated course, which is ages 10 to 18, and it gets you through the basics a little bit faster. And it is an accelerated version of courses 2 through 4. When we scroll down, you'll see some familiar characters. This is for the Hour of Code. If you wanted to, as a teacher, just kind of get your students interested in coding on not maybe a daily or even weekly basis, but a one-time thing, you can do the Hour of Code, and they have several different options for that using very well-known characters that students will get excited about. So we see Star Wars, Minecraft, Frozen. You can tell just from looking at this one page of the website that these are going to be very engaging lessons for students. If we go back up, I'm going to go ahead and start us on Course 1. One of the things I really like about Code.org, it has everything laid out for you exactly the way that it should be done. And it also has unplugged activities. So these are activities that you don't even need a computer for. And they're a really good idea to help your students get the idea behind what is coding. So if we go into the first unplugged activity, there's a video here and a lesson plan on how to teach your students what an algorithm is. They learn real coding vocabulary even when they start even at the age of 4 or 5. We go back again and go ahead and go to the first activity that you need the computer for. It's called Jigsaw Learn to Drag and Drop. So you click on the one. There's a video, and again we can skip over that. It tells us what we're going to be needing to do for this particular puzzle is to drag the block to the target. You just click on OK, and then you do as it says. Now again, this is for your youngest students. We've completed puzzle 1, and it automatically moves us on to puzzle number 2. Okay, now if you want to, I'm going to go back here. You can start at any level. So if you feel like the learning to drag and drop is something your students don't need, you can move ahead to something else. I'm going to switch, take us all the way down to stage 7, which is B sequence. And again, we're going to skip the video. All right, so what it wants us to do here is to move the bee to the flower, get the nectar, then move the bee to the honeycomb and make honey. All right, so now we're getting into the actual coding. So it says when, run, and then we have these different things that we can make our bee do. Move to the east, to the west, get the flower, make the honey. This is obviously teaching kids some really good skills, things like east and west, and the step-by-step process. This is a pretty simple one. we're going to drag our code over and make our bee go 1 block east. And then the flower's there, so we're going to get the flower. Then we need to move 2 more blocks, going the same direction. We grab 2 more, and then we make the honey. Okay, so this is our code. When we think we have it right, we click on Run and see what happens. Okay, and congratulations, we completed the puzzle. We just wrote 6 lines of code. So if we click on Show Code, it shows you what everything we just did would look like in code. Okay, now what I really love about it too is it helps students with some critical thinking and problem solving. So let's say this time that I am, you know what, I'm going to purposely do the wrong thing. Okay, so I'm going to move 1 block north, and then I'll move 1 more north. I will get my flower. Okay, and then go east, east, and make my honey. Okay, so this time when I click on Run, okay, my bee cannot go north. So now I have to think about what can I do to change that. What did I do wrong, and what do I need to change it? And they are on this level telling me what I should maybe try using, which is my south button. So I just click Try Again. I move everything out and I start over again. So now I'm going to go south. Okay, and write my code. Run it again. And that time I was successful. These can be great activities to have students do together. Put a couple of kids on a computer and have them work together to problem solve, because it does get much more difficult as you go. Again, we started on the easiest levels for the youngest kids, like kindergarten probably, but it can get quite a bit more complicated. The kids love it. I did this at a STEM night at my school, and I had some students who, rather than go to the different stations, just stayed at the coding station the entire time, which was the one that I was running, and these were 5th graders. They were very much engaged in the coding. They really ate it up. I would love to do something like this in my classes. However, I do not have the technology access. I'm going to go ahead and move over to course 2 real quick. I'll probably find one that's too hard for me, but you'll see the things that we're learning are algorithms, sequencing, looping, debugging. Kind of helps the kids understand that, well, if I have a problem, what is it that I need to fix? You can see that they're learning real coding vocabulary, and that's what the unplugged activities really do for you, is they can help the students to understand this vocabulary. Many of those unplugged activities involve movement and physically modeling what is happening when you write the code. So I will pick a loop, stage 8 bee loops. Hi, I'm a bee. Can you help me collect the nectar from these flowers? Okay, now we have a little bit more complicated. It's not giving me the arrows now. I have to tell it to move forward, tell the bee. We're going to go ahead and move forward, and we're going to move forward twice. We will get our nectar, move forward, get our nectar again. You'll notice the 1 next to the flower. If that said 2, then I would need to put get nectar over there twice. And then I believe I make honey. Ah, you can only get nectar from a flower. Try again. Okay, so what I did wrong, I would look at this now. I would look at what went right and then where was there a problem. And so what I see happened was I did not move forward enough blocks. I need to move forward again so that I'm at the flower. So this is great for critical thinking and problem solving. So we will take out the part that didn't work, which is very easy. Just drag it over and it goes away. We move forward again and get some nectar. Okay. You'll see that it's keeping track of all of the coding that I've done. Again, students can create an account so that they can keep track of what they're doing. This is a go at your own pace kind of activity, which is another thing about it that's really nice. The students who need to take extra time can do that. The students who get it right away can just take it as far as they want to. Okay, now they're asking about the loops. All right, now the reason it's a loop is because I am going forward, getting nectar, going forward, getting nectar. So I will do this one as well. We're going to move forward 2. Oh, just a sec. We're going to repeat. Move forward. And we're going to move forward twice. Get our nectar. And again, we move forward twice. Whoops. And get nectar. This part, you can see it's getting just a little bit more involved. Okay, now it says I completed the puzzle, but I could have used only 5 blocks. So now I could go back and try to do it again and be more efficient so that I'm only using 5 blocks. So I'm hoping that this helps you to see kind of what code.org is all about. It's a wonderful program that I would highly, highly recommend to anybody who wants to get kids involved with computer science and coding. Thank you.